Definition: Machine learning. Machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. Machine learning focuses on the development of computer programs that can access data and use it learn for themselves. Example: a machine learning algorithm usually follows a certain type of data and then uses the patterns hidden in that data to answer more questions. For example, showing a computer a series of photographs, some of which say that this is a horse and some of which say, this is not a horse. After this exercise, if you show some more photographs to the same computer, it will be on a mission to identify which of those photographs are of a horse and which of those are not that of a horse. Every correct and incorrect guess of the computer is added to its memory, which makes it smarter in the longer run and enriches its learning over a period. Methods of machine learning. Supervised machine learning algorithms. Unsupervised machine learning algorithms. Semi-supervised machine learning algorithms. Reinforcement machine learning algorithms. Supervised machine learning algorithms. Supervised machine learning algorithms can apply what has been learned in the past to new data using labeled examples to predict future events. Starting from the analysis of a known training dataset, the learning algorithm produces an inferred function to make predictions about the output values. The system can provide targets for any new input after enough training. The learning algorithm can also compare its output with the correct, intended output and find errors in order to modify the model accordingly. Unsupervised machine learning algorithms. In contrast, unsupervised machine learning algorithms are used when the information used to train is neither classified nor labeled. Unsupervised learning studies how systems can infer a function to describe a hidden structure from unlabeled data. The system doesn't figure out the right output, but it explores the data and can draw inferences from datasets to describe hidden structures from unlabeled data. Semi-supervised machine learning algorithms. Semi-supervised machine learning algorithms fall somewhere in between supervised and unsupervised learning, since they use both labeled and unlabeled data for training, typically a small amount of labeled data and a large amount of unlabeled data. The systems that use this method can considerably improve learning accuracy. Usually, semi-supervised learning is chosen when the acquired labeled data requires skilled and relevant resources in order to train it, learn from it. Otherwise, acquiring unlabeled data generally doesn't require additional resources. Reinforcement machine learning algorithms. Reinforcement machine learning algorithms is a learning method that interacts with its environment by producing actions and discovers errors or rewards. Trial and error search and delayed reward are the most relevant characteristics of reinforcement learning. This method allows machines and software agents to automatically determine the ideal behavior within a specific context in order to maximize its performance. Simple reward feedback is required for the agent to learn which action is best. This is known as the reinforcement signal. Industry use cases of machine learning. Financial services. Marketing and sales. Government. Healthcare. Transportation. Oil and gas. Financial services. Companies in the financial sector can identify key insights in financial data as well as prevent any occurrences of financial fraud with the help of machine learning technology. The technology is also used to identify opportunities for investments and trade. Usage of cyber surveillance helps in identifying those individuals or institutions which are prone to financial risk and take necessary actions in time to prevent fraud. Example: ML also has a significant impact on the finance sector. Some of the common machine learning benefits in finance include portfolio management, algorithmic trading, loan underwriting, and most importantly, fraud detection. In addition, according to a report on the future of underwriting published by Ernst & Young, ML facilitates continual data assessments for detecting and analyzing anomalies and nuances. This helps in improving the precision of financial models and rules. Marketing and sales. Companies are using machine learning technology to analyze the purchase history of their customers and make personalized product recommendations for their next purchase. This ability to capture, analyze, and use customer data to provide a personalized shopping experience is the future of sales and marketing. Example: product recommendation is an important aspect of any sales and marketing strategy, including upselling and cross-selling. ML models will analyze the purchase history of a customer, and based on that they identify those products from your product inventory in which a customer is interested in. The algorithm will identify hidden patterns among the items and will then group similar products into clusters. Government. Government agencies like utilities and public safety have a specific need for ML, as they have multiple data sources, which can be mined for identifying useful patterns and insights. For example, sensor data can be analyzed to identify ways to minimize costs and increase efficiency. Furthermore, ML can also be used to minimize identity thefts and detect fraud. Example: public sector agencies are making use of machine learning for government initiatives to gain vital insights into policy data. Machine learning systems are also used for filtering citizen policy data and automatically alert executives about legislation or regulations that can potentially affect them. Healthcare. With the advent of wearable sensors and devices that use data to access health of a patient in real time, ML is becoming a fast-growing trend in healthcare. Sensors in wearable provide real-time patient information, such as overall health condition, heartbeat, blood pressure, and other vital parameters. Doctors and medical experts can use this information to analyze the health condition of an individual, draw a pattern from the patient history, and predict the occurrence of any ailments in the future. The technology also empowers medical experts to analyze data to identify trends that facilitate better diagnoses and treatment. Example: in healthcare industry, ML helps in easy identification of high-risk patients, make near-perfect diagnoses, recommend best possible medicines, and predict readmissions. These are predominantly based on the available data sets of anonymous patient records as well as the symptoms exhibited by them. Near-accurate diagnoses and better medicine recommendations will facilitate faster patient recovery without the need for extraneous medications. In this way, ML makes it possible to improve patient health at minimal costs in the medical sector. Transportation. Based on the travel history and pattern of traveling across various routes, machine learning can help transportation companies predict potential problems that could arise on certain routes, and accordingly advise their customers to opt for a different route. Transportation firms and delivery organizations are increasingly using machine learning technology to carry out data analysis and data modeling to make informed decisions and help their customers make smart decisions when they travel. Example: mobile apps are a crucial part of any transit business. They enable passengers to make purchases, check schedules and statuses, find nearby stations and attractions, and much more. Machine learning ensures front-end features of the apps, such as location tracking, notification systems, and suggestion features, are backed by rich data sets that continually adjust and improve over time. Oil and gas. This is perhaps the industry that needs the application of machine learning the most. Right from analyzing underground minerals and finding new energy sources to streaming oil distribution, ML applications for this industry are vast and are still expanding. Example: oil and gas firms have corrective as well as preventive maintenance practices in place. However, these are often costly and inefficient. This is exactly where ML can be of great help. ML helps in the creation of highly efficient predictive maintenance plans. Following such predictive maintenance plans will minimize the chances of unexpected failures, thereby reducing unnecessary preventive maintenance activities. Benefit, features of machine learning. Massive data consumption from unlimited sources. Rapid analysis, prediction and processing. Simplifies time-intensive documentation and data entry. Easy spam detection. Better customer segmentation and accurate lifetime value prediction. Massive data consumption from unlimited sources. ML virtually consumes unlimited amount of comprehensive data. The consumed data can then be used to constantly review and modify your sales and marketing strategies based on the customer behavioral patterns. Once your model is trained, it will be able to identify highly relevant variables. Consequently, you will be able to get focused data feeds by foregoing long and complicated integrations. Rapid analysis, prediction and processing. The rate at which ML consumes data and identifies relevant data makes it possible for you to take appropriate actions at the right time. For instance, ML will optimize the best subsequent offer for your customer. Consequently, the customer will be able to see the right offer at a given point of time, without you investing time to plan and make the right ad visible for your customers. Simplifies time-intensive documentation and data entry. Data duplication and inaccuracy are the major issues confronted by organizations wanting to automate their data entry process. Well, this situation can be significantly improved by predictive modeling and machine learning algorithms. With this, machines can perform time-intensive data entry tasks, leaving your skilled resources free to focus on other value-adding duties. Easy spam detection. Spam detection was one of the earliest problems solved by ML. Few years ago, email providers made use of rule-based techniques to filter out spam. However, with the advent of ML, spam filters are making new rules using brain-like neural networks to eliminate spam mails. The neural networks recognize pushing messages and junk mail by evaluating the rules across a huge network of computers. Better customer segmentation and accurate lifetime value prediction. Customer segmentation and lifetime value prediction are the major challenges faced by marketers today. However, accurate predictions for incentives and individual marketing offers can be easily achieved with ML. Savvy marketers now use ML to eliminate guesswork associated with data-driven marketing. Illustrative example. These are some of the companies offering solutions and offerings for machine learning: AWS, Google, IBM, Microsoft, NVIDIA, Splunk.